Good morning. It's now 7 o'clock at the Springhill Marriott, Newark International Airport. And as promised, after taking a break, that I will return to demonstrate the PDA methodology and with the general 5 by 12 matrix. And this 5 by 12 matrix have been really doing some great works, some amazing works, I would say. With it, we have derived magnanimous amount of 1 by 11 or 12 outputs, probability of infinity outputs, are the terminologies that describe it. Serials like sand output, millions, billions, trillions, quadrillions of 1 by 11 outputs by repeated processing of the 5 by 12 matrix. And this is the general form. A, B, C, D. A, B, C is in, you note, is in the uppercase. And A, B, C, D, E, F, G, H is in the lowercase. This is the way it will remain in the finals. These three in the uppercase, A, B, C, could be not necessarily consecutive alphabets, but for here, for the demonstration, you know that these are consecutive alphabets. GHI, JKL, MNO, they are consecutive. But in normal life, they could be random. GMNO, JMK, MMN, random, not necessarily in order. And the lowercase would be numbers or numericals, digits. But for this algebraic sort of demonstration, we have it in the algebraic letter form. And as you know, here we start giving Greek because I run out of English alphabet. GHIQRSTUVXX and JKLYZ are saying I know alpha, beta, gamma, delta, pi. This is what? This is pi. Omega, the lowercase omega here. And here we have some Greek. This is now Aleph. I think this is Bet. This is Dalet, Yod, Yu, A, Va, and this is Kaf, I believe. So this is 1, 2, 3, 4, 5, 6, 7, 8. This is not in it because this is supposed to be lambda. So this little piece here is not in it really. And this is Kaf. Well, I'm not an expert at the Hebrew alphabet, but here are some. Now this is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 columns and 5 rows. 1, 2, 3, 4, 5. So we call it a 5 by 11. And this extra column here is isolated. But you know this extra column, it always take the median or the middle of these three uppercase. So if this is A, B, C, this is B. And usually there's also some subscript here or superscript or even numbers adjacent to this isolated one. This is DEF, so this would be E, and it could be E with a subscript or with an adjacent numericals there, like E6, E sub 6, or E7. GHI, H is the middle, JKL, K, and MNO, N is the middle. So the 12th column takes this form, with this being the middle. And specifically now, we set up now a specific matrix with ABC, And like as I tell you, this could have been AMO. Doesn't necessarily have to be consecutive numbers. Or this could be DMN. Or this could be GOP. This could be LLD. This could be MNI. Not necessarily consecutive alphabets in order. All right, and I assume some random numbers, arbitrary digits, to make up the 5 by 11 here. 1, 2, 3, 4, 5, 6, 7, 8, and 3 is 11. All numericals. Random thought up digits are numericals. And here again, this takes the form E, the mid of these three uppercase. And so by the PDM methodology now, we start to operate. We take the ABC out, and we're left with this matrix here. The I, J, K, L, M, N, O, P, Q, R, S, T, U, V. This is this. But in the numerical form, ABC would deal with it with 11 65 9720 2279 9564 00742997, which is this matrix. And likewise, DEF, by the PDA methodology, we'll get this matrix from this. And GHI, likewise, this from this. So A would correspond to 3 here, and randomly U, QRST, U would correspond to the 4th one here, which is 9, and say Aleph would correspond to 1, and Kaf would correspond to 4. So by the PDA methodology, we got all these matrices coming down here. Yeah. And our objective was to return a specific 1 by 11 in this form, but it would be unique or different from the original one used in this model matrix, which is, we call this source matrix, the model matrix, right? And so this was one step of the processing. The next step would have been I started the next step here, ABC 13, ABC 11. So ABC is operating, and ABC 11 and then we get this matrix, ABC 22, and we get this 1, 2, 3, 4, 5, 6, a 3 by 6 matrix, but we are operating or fishing by 2s, so this would be now a 3 by 3 because we are actually doing the algorithm pairing them off. So although it's 1, 2, 3, 4, 5, 6 columns and 3 rows, it's actually 3 rows and 3 columns because we are working in pairs. ABC 00. ABC 00 will be this one. After we operate with ABC 00, we'll be left with 65, 97, 20, 65, 97, 20. ABC 00, we're left with 77, 95, 64, 77, 95, 64, and 59, 21, 74, 59, 21, 74. That's by the methodology. And if we take a random one, so ABC 6 to 5, ABC 6 to 5, we're fishing by 2s now, we're working with 2s. ABC 6 to 5, ABC, and we're 6 to 5. 6 to 5 is right here. We came down so, and we go up to right here. And if we use the methodology now, we get 22, 95, 64, 22, 95, 64. 29, 97, 29, 97, and 13, 21, 74. 13, 21, 74. And so if we say choose this one, I guess you can't see this below here. So let's choose one because of the setup of the camera. So let's choose, let's say this one, ABC 74. ABC 74 would be here. So we'd have now 65, 97, 20, 65, 97, 20, ABC 74. 11, 97, 20, 11, 97, 20, 74, 22, 95, 64, 22, 95, 64, ABC 74, and 13, 21, 74. Now the next step would to get ABC 11, 77, ABC 11, 74, ABC 11, 59. But like I told my students that an experienced PDM processor, one experience with this algorithm and with this processing would, after deriving it to this stage, you would derive the final output just from this stage. For me, from my doing the revision to this stage, I would actually start generating the 1 by 11. So I would say, because I'm experienced, I would say this the output for this would be ABC 11, 77, 29, 74. That would be 1. Then there will be ABC 11, 77, 97, 21. Then there will be ABC 11, 77, 74, 29, and ABC 11, 77, 21, 97. So you'd have 4 ABC 11, 77. 4 different ABC 11, 77. But there is a chance to make mistake from this stage of the processing. So you could bring it down to a 2 by 2, and then you derive the final output, the final 1 by 11. Well, here we are. I would say, no, this would be ABC 11, 74, which would be the next one, right? And then, so the next output would be ABC 11, 74, 95, 74, ABC 11, 74, 64, 21, ABC 11, 74, 74, 95, and ABC 11, 74, 21, 64. That's the methodology. And like as I said, it's easy to make mistake doing abstract and mental derivation from this process. So we go on to a further step, which I've shown in other session. So you'll also get now 4 different ABC 11, 74. The next one will be 59. We're working in pairs. We're fishing by twos. ABC 11, 59. 95, 97. ABC 11, 59. 64, 29. ABC 11, 59. 97, 95. And ABC 11, 59. 29, 64. So we get ABC 11, 59, 4 different ABC 11, 59. 11, 59. So the next one here will be, we go down so that we are fishing by twos. We're working with this tool now. ABC 11, 21. So we cross off this column and this row in our minds, and we're left with this, this, and this. So the output would be ABC 11, 21, 77, 97, ABC 11, 21, 64, 74, ABC 11, 21, 97, 77, and ABC 11, 21, 74, 64. So that would be now 4 unique output with ABC 11, 21. And randomly now, likewise and similar, we would do ABC 11, 29 and get 4 unique output for that. Let's do it. And ABC 11, 29, we come down so and we strike out this column and strike out this row. So we're left with 77, 59, 74, and 64 because we have to strike out these. And so the output would be ABC 11, 29, 77, 97, ABC 11, 29. This is out, and this is out. ABC 11, 29, 77, 74, ABC 11, 29, 64, 59, ABC 11, 29, 74, 77, and ABC 11, 29, 59, 64. So the next one here would be 4 unique outputs for ABC 1195. We're fishing by twos here, we're working in pairs. ABC 1195. So we come down, we strike out the ABC 1195. We left with 74, 97, 74, and 59. So the output would be ABC 1195, 74, 74, ABC 11, 95, 97, 59, ABC 11, 95, 74, 74, and ABC 11, 95, 59, 97. And so similarly for the 64, 97, let's do the last one, ABC 11, 74. So we strike out 74, so, and so, and we're left with this. So the output would be ABC 11, 74, 77, 29, ABC 11, 74, 95, 74, ABC 11, 74, 29, 77, ABC 11, 74, 74, 95. So we have 4 unique outputs. And we'll do this for the DEF, GHI, JKL, MNO. And you'll see how many different outputs we'll get after we've finished this processing. An exponential amount. And by repeated processing, using different inputs, 5 by 12, we'll get different outputs. Now, like I said, now this algorithm, the product or the output, has application in STEM, which is STEM, you know, is S for science, T for technology, E for engineering, and M for mathematics. But it's extended to, I've applied it now to, and call it STEM3. STEM3 is now science, technology, engineering, mathematics, medicine, and music. So this PDM processing has all STEM 1, STEM 2, and STEM 3 application, where the extension of the M is now medicine and music. And thus normal STEM means science, technology, engineering, and mathematics, but STEM 1 would be science, technology, engineering, mathematics. Medicine, or rather STEM 1 would be that. STEM 2 would be science, technology, engineering, mathematics, and medicine, or science, technology, engineering, mathematics, and music. STEM 1, STEM 2, and STEM 3. Likewise, we could have, I call it a T-star, with the T, no, not technology, but for teaching. So this thing has an application in teaching as well. So it has, as I would say, multidimensional application. So I just want to briefly introduce the PDM methodology and hope you will absorb it and come up with some other application that we could apply this thing. And so let us try to all have a better quality life by having optimal application from this PDM methodology. There's much more to it, and I can't explain this in this short session, but this will be all for now, and thank you so much.